Good evening, everyone. I hope my voice is audible to you all. Today, let me discuss the the problems which are in complex numbers. I discussed all the concepts. Of course, Eulerian form is one method. Let the problem comes at that time I will discuss, right? Give me 1 minute time. I will rub the board, please. Yes. Good evening, everyone. Write down the problems which are related to complex numbers. Root 5, root of minus 5 into root of minus 125 is equals. Find the value of this number. And the second problem it is I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3 is equal. Now, first of all, let me discuss these problems, right? Root of minus 5 value is equal to root of minus 1 into root 5, right? Into root of minus 1 into root 125. Root of minus 1 is equals to I root 5 into I root 125. I square into root of 625, which is equal to I square value is minus 1. This is 25 again. So you are going to get minus 25 is the answer for this question. Copy this one. Now, let me discuss this problem. I power n plus I power n into I plus I power n into I square plus I power n into I cube. Okay. Now, take I power n common. 1 plus I square plus I cube you are going to get. That means I power n as it is, right? 1 plus I square value is equal to minus 1. I cube value is equal to minus I. Now minus 1 plus 1 get cancelled. You are going to get 0 into I power n is equals to 0. Copy this one. Next problem. The least value of n for which 1 plus I whole power n upon 1 minus I whole power n minus 2 is a real number. It should be a real number. Observe. Of course, you can do this problem by using two methods. Let me go to the shortcut method by verification called 1. First option is 1. Second option is 4. Third option is 6. Fourth option is 14. Now, how to do this problem? Observe here. Substitute n is equal to 1. I am going to get 1 plus I by 1 minus I power minus 1. Sorry, minus 2. Why? Because this is 1 minus 2 is equal to minus 1, which you can write this one as 1 plus I into, if this goes up, it becomes 1 minus I. A plus B into A minus B, A square minus B square. 1 minus I square. I square value is minus 1. So 1 plus 1 is equal to 2 is a real number. So the least positive integer, it is equals to 1 itself. Copy this one through verification. One plus I power 6 plus 1 minus I whole cube. Today, let me do the problems which are in our material. Tomorrow, I will complete the problems related to complex numbers in exemplar problems. At that time, we can complete the problems on CET level. After that, let us do some problems in JEE main. One plus I whole power 6. See here, as here it is 6. Okay, you can write this problem as 1 plus I whole cube whole square, right? Or whole square whole cube, whatever it may be, plus 1 minus I whole cube as it is, right? Now this is in the form of a plus b whole square. A square 1 plus b square plus 2ab whole cube plus a cube minus 3a square b plus 3a b square minus b cube. That means I square value is minus 1. This and this get cancelled. It becomes 8I cube plus 1 minus 3I minus plus, see here, it becomes I square value minus 1. It is minus 3 minus I cube. Minus I cube means minus of I cube is equal to minus I. It becomes plus I. Right? Now, this is I cube value is minus I. So it is minus 8I. Now, just observe this one carefully. Minus 2 minus 3I plus I minus 2I minus 2i minus 8i minus 10i. So you are going to get minus 2 minus 10i is the answer. These are all the problems which are related to CET level. After completion of this, let us discuss JEP. The multiplicative inverse of 3 plus 4i by 25. He asked you to find out the multiplicative inverse of 3 plus 4i by 25. Generally, what is called multiplicative inverse, right? First of all, let me write the formula for it. The multiplicative inverse of z is equal to x plus iy is equal to x minus iy by x square plus y square. X minus iy by x square plus y square means what is x minus iy? 3 minus 4i by, okay, otherwise better to do like this. Okay, now you just consider this one as a plus ib form like this, very easy to do, plus ib form, right? So x minus iy by x square plus y square. If we simplify this, you are going to get 3 minus 4, right? Copy this one. Now, the additive inverse of a complex number, he asked you to find out this. But first of all, you should know what is called additive inverse of z. See here, the additive inverse of x plus iy z is minus z. Means if z is equal to x plus iy, the additive inverse of z is equals to minus x minus iy. Means see here, z is equal to 1 plus 2i into 3 minus 4i, right? Now multiply these two, 3, okay, minus 4i plus 6i minus 8i square. Wherever there is I square, substitute minus 1. We are going to get 3. Here it is minus of minus becomes plus 8. 3 plus 8 becomes 11 plus 2i. This is the value of z you got. Therefore, the additive inverse of z minus z is equal to minus 11 minus 2i. Copy this one. Whatever it may be, first of all, you should convert that in the form of a plus ib. Next, put n is equals to 0. First of all, expanding sigma. Sigma n is equal to 0 to infinite 2i by 3 whole power n. First of all, substitute n is equal to 0. Anything to the power of 0 value is equals to 1. So 1 plus, put n is equal to 1. We are going to get 2i by 3 plus by 3 whole square up to infinite. This is called geometrical progression. S infinite is equal to a by 1 minus r, where a is the initial term, r is the common ratio, means which is equal to a by 1 minus r value is equal to 2i by 3, which is equal to 3 by 3 minus 2i, right? So multiply and divided by 3 plus 2i, we are going to get this one. So 3 3s are 9 plus 6i by a minus b into a plus b is equal to a square plus b square. So which is equal to 9 plus 4 is equal to 13. So 9 plus 6i by 13 is the answer. I am repeating this problem again. This is in the form of, see, expanding sigma. You just expand sigma value by substituting n is equal to 0. If I substitute n is equal to 0, you are going to get anything to the power of 0 is 1 plus 2i by 3 plus 2i by 3 whole square and so on up to infinite, right? So this is in the form of a by 1 minus r form. So a by 1 minus r. So 3 by 3 minus 2i into 3 plus 2i by 3 plus 2i. So 3 3s are 9 plus 6i by a minus ib into a plus ib. You should remember directly a square plus b square, which is equals to 13. Copy this one. Next problem. Next problem. Express 2 plus 3i by 2 minus 3i minus 2 minus 3i by 2 plus 3i in the form of a plus ib. In the form of a plus ib. See how to do this. First of all, take the LCM of denominator, means the LCM becomes 2 minus 3i into 2 plus 3i and 2 plus 3i whole square minus 2 minus 3i whole square, which is equal to a square minus b square is equal to a plus b. See here, a square minus b square can be written as a plus b. A plus b value is equal to 4, right? Into a minus b. A minus b value is equal to 6i upon, right? Here you are going to get a plus ib into a minus ib, a square plus b square. So you are going to get a square plus b square, which you are going to get 24i upon 13, where you can write a value is equal to 0, b value is equal to 13. A plus ib form na. Now the next problem. Z is equals to He asked you to find out the conjugate of that complex number. First of all, you should write that complex number in a plus ib form. What is the meaning of the word conjugate called? If z is equal to x plus iy, the conjugate of z is nothing but z bar. Z bar is equal to x minus iy. So first of all, if you want to write the conjugate of any complex number, you need to write it in a plus ib form. So you write this in a plus ib form like 2 minus I upon a square plus b square minus 2ab, which is equals to 2 minus I upon I square value is minus 1. So this becomes minus 3 minus 4i. Take the conjugate of this and multiply and divide with this one. You are going to get 4i by minus 3 plus 4i. Okay, we are going to get 3 2's minus 6, right? And plus 8i plus 3i minus 4i square, which you are going to get as 4 by a plus b into a minus b is equal to this. So you are going to get minus 2 plus 11i by 25. This is z. He asked you to find out z bar. Z bar implies minus 2 minus 11i by 25. Copy this one. Now let us do the problems on modulus. Modulus of, find the modulus of root 3 plus I upon 1 plus I into 1 plus root 3I. Find the modulus of root 3 plus I upon 1 plus I into 1 plus root 3I. Now, we are having one formula related to this modulus. See, whatever you want to do, generally, what is the concept of modulus? Z is equal to x plus iy, mod z value is equal to root over x square plus y square. To write the to find the modulus of any complex number, we need to write it in a plus ib form. But it becomes lengthy if I write that in a plus ib form. So I am going to connect with one formula which is called a shortcut or property of modulus. What it is? Mod of z1 upon z2 is equal to mod z1. Mod of z1 upon z2 is equal to mod z1 by mod z2. And We are having another property mod z1 into z2 can written as mod z1 into mod z2 separately. Okay, so by this one, see, observe, you can write the modulus of mod of 3 plus 3 root 3 plus I upon mod of 1 plus I into mod of 1 plus I root 3. So you can write this one as root over 3 root 3 square plus 1 square upon root of 1 plus 1 into root of 1 plus root 3 square. That means if you simplify this, you are going to get 2 by root 2 into 2, which is equal to 1 by root 2 is the answer. What is the intent? That means what is the inner meaning of this problem is, if he asks us to find out the modulus of any total complex number, you can write the modulus separately and you can find the modulus individually. See here, mod of alpha plus I beta by beta. That means, see here, alpha comma beta are real. Means they are constant. See, you can write mod of, see, you can write this one as mod of alpha plus I beta by mod of beta minus I alpha by using this property. Okay, so we can write this one as root over alpha square plus beta square upon, okay, root over beta square plus minus alpha whole square. Minus alpha whole square value is equals to alpha square plus beta square by alpha square plus beta square, the value it is equals to 1. Copy this one. As we are having very few problems in exemplar book, okay, we are going through the material again. Tomorrow I will discuss these exemplar book problems, right? If it is possible, you just get your exemplar PU, that means first PU, okay. And now next problem. If root 3 plus I power 100 is equals to 2 power 99 into A plus IB, then he asked you to find out A square plus B square. Now, taking modulus on both sides, we are going to get right. Taking modulus on both sides, we are going to get this, right? Now, what is the value of mod of root 3 plus I? It becomes square root of root 3 square plus I square. That is 1 square, okay? Which is equal to 2 power 99 into root over a square plus b square, okay? Now, this is the value for square and root get cancelled. 2 is 2 power whole power 100. I'm sorry, whole power 100. That means you are going to get 2 to the power of 100 is equal, this value becomes 2. 2 power 100 is equals to 2 power 99 into root over a square plus b square. Okay. Now, which is that means root of a square plus b square value is equals to, you are going to get 2. He asked you to find out the value of a square plus b square. Then squaring on both sides, you are going to get the value is called 4. Open this one. That means the first step I am repeating, you just take the modulus on both sides, applying modulus, we are going to get 2 power 100 is equal to 2 power 99 into root over a square plus b square, but the question it is a square plus b square. So if I square on both sides, I am going to get a square plus b square value is equals to 4, right? Copy this one. Okay, tomorrow we can discuss the problems related to complex numbers in exemplar problem. You just get exemplar book if it is possible to you, right? That exemplar book represents the it is CET level. After that, let me finish JEE. Thank you and have a nice evening.